Hey, what's up YouTube? Today we're going to be talking about the derivatives of parametrically defined equations. So before we get into the derivatives of them, we're going to be talking about what parametric equations are. So parametric equations are when we have two variables expressed in terms of one of the same variable, i.e. the parameter. Most commonly, this is used to express y and x in terms of the same parameter, t, or time. So let's say we have that y is equal to t plus 1 and x is equal to t squared. Then we can obviously express y in terms of x. So if t is equal to radical x, then we can just say that x is equal to, or y is equal to radical x plus 1. However, this is a very simple example. This is just review, of course, but let's try and find the derivative of this. And the derivative we're trying to find is dy with respect to dx. Now, it's not going to be as simple as just rewriting it. A lot of time things are written as parametric equations just because they're simply written that way for simplicity, is what I meant to say. So before we get into finding this derivative, we're going to go off to this side over here and kind of review knowledge about fractions. If the numerator and the denominator have the same fraction, then they would cancel out, but it means the same thing. So for example, 1 is equal to 1/2 divided by 1/2. In similar terms, you could say that the derivative of y with respect to dt is the same divided by dx over dt is the same as dy over dx because the dt's will cancel out. Now, the reason why we're writing it this way, though, is because it's defined parametrically. So we don't know what dy or dx is, but we know what dy over dt is, and we know what dx over dt is. So in this example, we have that the derivative of y with respect to t here is 1 because just use the power rule, and over here it's just 0. And we divide that by the derivative of dx over dt, and that's just 2t. So you have 1 over 2t. And that would be your answer. Now, the last thing we need to cover is just what the second derivative of this would be. So the second derivative would be the derivative with respect to x of dy over dx. Now, remember this is with respect to x, so let's apply the fraction theory, dividing it into fractions again. We have d with respect to dt of dy over dx, which we know we can find because that's this over here. So, remember, we're doing this into the entire numerator now. And then we're going to divide that by this denominator, dx over dt. So, that would be how you find your second derivative. But let's actually use the example. So the derivative with respect to t of this, now we're going to basically rewrite this over here as 1/2 times t to the negative 1 so that it will be easier to use our power rule. So the derivative of that would be negative 1/2 times t to the negative 2, or negative 1/2 over t squared. This is just the power rule. Because remember, you bring down your negative, your exponent, and then you lower it by 1. So that's what you end up with over here. And then you divide that by dx over dt, which is over here going to be 2t. And then we can simplify that to be negative 1 over 4 times t to the third. And that is basically how you find the derivatives of parametrically defined equations. I hope you enjoyed this video, and I'll see you tomorrow.